Okay, so let's get into objects. Okay, so let's continue with objects. So we're looking at objects here. So the first object you have, so I said like you have the name. So let's do this. We have the name on the side. Wait, let me just zoom up. So this is where I'm here. Okay, just note this. Note something small in Jupyter. So say now you want to put a cell below this. Like just look here. So you see it's green. Can you guys see that it's green? Click on it, now it's blue. And you click B below and then it will add another cell. Okay. B, add another cell. If you want to add another cell above it, click on it, it's blue, you press A. Okay. If you want to delete a cell, press D twice and delete them. So just small shortcuts, and if you want to add lines, you press L. Okay, cool. Write it down. So Jupyter Notebook shortcuts, click on it and then it's blue. You just press A on the keyboard. Good. And it's above. It adds one. You see? Just do that. Click on, make it blue, press A. A. Yeah. Just A. Did it add one? Make it blue and press A. Did it add one? Now if you want to delete that cell, press D twice. Just press D twice. Deleted. If you want to add one below, press B, and then you can delete it. Okay, just small things. And then if you want to add lines, make it blue and just press L. It's very like intuitive, you know, like lines for L, A for above, B for below, D for delete. Lines, yeah, and it becomes important because let me show you something. Let me show you a code I did, right? I did this code like a while back. And I love using this code as an example. So if you look at this code, this is a 900 line code that I did. Right, and it looks very complicated and it's like got a lot of indentation and it's like what the hell's going on? I don't know. It's basically an AI, it's like a Sudoku solver. So you know Sudoku puzzle? It's like the brain that can solve any Sudoku puzzle, like so you can give it the toughest Sudoku puzzle, like that takes experts like I don't know, like a minute to solve. This thing will solve it in like 1 second. And it's yeah, but that's what's nice about Python. You can do stuff like this, right? But the code, it becomes important because when you make mistakes and stuff, you want to know like what line it is, what mistake the line is in. And, I mean, if you just got like this, if there's no lines, it's like what's going on?
If you run it and it says like it says one line of mistake.
Yeah, so just note that. Just put lines. I told you guys, I'm giving you every little small things. So yeah, we're looking at objects. So that's right. We're looking at objects. So we have the object name, right? And then we have the actual object. This side, the object. So this is just little notes I'm making so we know. And you remember the object is the value. So you can say the name is the variable, the object is the value of the variable, right? I just want you guys to enforce that in, like you get that idea. So we're going to see x is equal to 10. Now this is an integer. This is what we call an integer, right? And then we have our second, so what we're looking at now is we're looking at single objects. We're looking at single objects. Single objects, and then we have y is equal to 20. And then another type of object is a float. So 20.5 is an example. It's basically a float is a decimal. So with 20.5, which is a float, and this is known as a decimal. Right? And then we have z. We have z. Now we have z, which is equal to, so we have a float, and a float is like, it's any real number, right? It's any, so we can even have minus 20.5, and then we can have minus 10. Because remember, you have an integer, and then we have a float. Those are the two different. And then we have the third type of single object, which is known as a string, which is basically text. So let's say color. Let's say color is equals to red. right? Now when I print red, we're going to see, oh snap, name red is not defined. Okay, oh yeah, you see it gave us an error. Because we're supposed to say print color. So we print color, and we see it gives us red. You see that? This is actually a value. You can't do math to it. It's not like a standard math object, but it is something, it's like it's text. And I'll show you later why you need this text, like why a string is important. So we can even make a second color as an example, and we can make it blue, but we can use single tags. We can say blue, I'm going to say print color, and we'll, no. So we have color. Okay, look, if I run it now, we'll see that we get blue for both. Check here. We'll see both is blue, because how Python runs this code is it's gonna come here, it's gonna put this in its memory first, right? The name color. Remember, this is like, it's sensitive. Like, if it's color, that's what it is. And then it puts the same thing. It's the exact same thing. It's going to replace whatever was stored in there with the blue. And that's why when you print it twice, it's blue, blue. Make sense? So you have to say color 1 and color 2 to make them different. Then we have color 1 and we have color 2. And then I run it, and we'll see we get red and blue. Okay? Just some straightforward there. Those are basically strings. Okay, so this is a string type object. So the string type, or just a string. So this is a string with 2 commas, and this is a string with a single. They're the same thing. Don't worry about that. Okay, you can use anything you want there. Okay, and then the third. Okay, so this is, I'm going to put this here for single objects, right? So what I'll do here is I'll create one above, I'll just put that in here. So we have objects, and then this is for single objects, right? And then we have what's called container objects. Container objects. Yeah, so but this stuff makes sense, right? Like the single objects, right? Okay, but a container object, it's in the name. It contains a bunch of objects, right? So it contains a bunch of single objects, and the first type is a list. The first type of object is a list, and how we do a list is it's very simple. You just say b is equal to, and you add your different things. So remember, this is still the name. Remember, this still applies. This idea here still applies to whether it's to any object. We're looking at all object types. Remember that this object can either be a single object or it can be a container object. So we're going to say b then is equals to, say, 1, 2, 3 as an example. Okay, b is 1, 2, 3, and if you print b, okay, if you run b, we'll see we get 1, 2, 3 like this, right? And we're going to get a list back, chilled. And you can even put strings in here. You can put red, you can put any sub objects. You can put a float in there. You can say minus 8.1. You can even import, wait, let me do that in a separate cell. Okay, let's just say 1 here. And if you run it now, we'll see, you see red. Puts red there. Okay. No problem, I'll just wait for you. Yeah, so you see the time is there. We are hour and a half in. I'm going to just finish going through lists, and then I'm going to start with arrays, okay? We'll take a break, and then we'll do arrays afterwards, and then we'll do problems. Wait, before I finish with this, that's how you define a string. That's how you do it. So if you leave it out and just say red, it's going to give you an error because it's like, wait, what's? Remember, the only time you can leave plain text is when it's a name. Because on this side, see, there's the name. On this side is the object. be in this text here. It has to be in inverted commas. Or what you can also do is another way you can define a string is you can say, but this is when you convert. So convert a number or convert a number into a string. To string. Yeah, so how you convert a number into a string, so you're going to say color. Okay, yeah, so wait. Okay, so say we want to convert this x into a string. All you're going to do is you're going to say x. You can even do this, like, remember that even if you save it as x and then you say string, str, that's a function that converts a number into a string. And then you say, you put x in here. So you have x there, right? So it's going to, remember, you need to understand this. How Python looks at objects, how it understands and how it sees objects, right? Is over here, there's not an x. There's a -10 to Python. To us, we see it in x, right? To Python, it's just a -10. So if there's -10 in there and we say string -10, x is equal to string x, there's no x, it's string -10. So it's going to set whatever x is to, it's going to replace the value. Okay, so just remember that. This is not x, this is a -10 because that's how we've defined it. Okay, so when I print it now and I say print x, we get -10. But now the difference is I can't go now and say +5 with a string because it's not the same type. You can only add the same type of objects together. Okay. Because it's math. You can only do math with the same objects. Okay. So so you can't say that. So if you run it now, right? But before that, look, if I said print over here x +5 and I ran it now, we'll see that it works, right? But remember, this -10 is not the same as, these are two different things. It looks the same, but to Python it's not the same because a string is something, it turns the text into a string, the number into a string, into text. Yes, in the beginning it did. If you say string +10 and you run it, you're going to give an error because it can only continuate string. So basically what it's saying, it can't put this, because this is a string, right? Remember, this is a string, it's text. Imagine you can't add, in mathematics, in WTW, right? You can't find, say, okay, like usually you would find, say, the integral of x or something, right? But x is usually a variable. It could be anything, right? But if, say, it was just something that was not supposed to be a number, say it was text, like pure, simple text, it was like a, I don't know, like laptop or something. Like it was just something that doesn't have any value, like no number in there. It's like empty. There's no number. It's just text. That's what a string is. So if you want to add something that's empty and doesn't have like any value to something that does, it's not the same thing, right? Does it make sense? So when I run it now, that's why it gives an error, because it's not the same. Okay, so this converts. Okay, so let me put that here. Okay, so you get the idea of a string now. Everyone cool? Yeah, Shoti? Alright. So let's run this thing. Yeah, so run it now, we see it's fine. Okay, but just note, write a note, take a note. This string is not this -5 is not the same. They're different values. It looks the same, but it's different. Okay. Take note. But note that you can do this. Inside the string, you can say +5 like this, because it's going to convert whatever the numerical value is of that into, you see. But they're two different things. Is it making sense now what I'm doing with this, right? So this is single object. Now we're looking at container objects, right? This is what I was looking at. So we have a list, and that contains different values, different. Yes, not like you can have different single objects. You can have a string in there. You can have a integer. No, in a float. You can have an integer, another float, an integer, right? And then it will return exactly that. Okay, so that's a container type. That's a list. And lists are fundamental. Remember, I'm explaining all the fundamentals. If you don't understand the concept of the list, if you don't understand the concept of single objects, Python is going to be a nightmare. No, and then let's look at list operations quickly. Operations. List operations. And these are basically things you can do to lists, which are nice. So each value in this list has what's this thing? Each value in the list has an address. It has a position in the list, right? Because it has to be, it's like a container. You know? Each thing has an address. So the first one is the 0th address or the 0th index. So an index, you'll see this a lot in Python, is equal to an address or position in the container type. The container type. Right? Yeah, square brackets, period. Standard square brackets. There's no other way around it. In other languages, it's different. Yeah, I recently learned C++ and JavaScript, so I have to think Python. It's difficult to. Yeah, so let's cool. So an index is an address. So just take a note. This is basically indices that we're going to look at. The first operation 1, is an indice. Hashtag number 1 is indices, which is an index, which is plural for index. Note that. Because you could get it in a test where he's like, find the indices. I've seen that in the past. Plural of plural of index. Right? So if you want to see the position, right, of anything, how you find the address, so you do this, right, call it int, whatever you want. Remember the names, you can call them whatever you want. So we have int is equals to b, and then if you want to get the reference of anything, right, if you want to get the reference literally or the address or the index of anything, like say we want to return this 3.5 here. That's what we want to do. We want to see what is the value at the 0, 1, 2, at the second index. Remember, it's 0, 1, 2, 3. So if I do this and I put 0 in here, we are going to get, I haven't printed it, you see, so I need to print int. Okay, we get 1 because you see the first value is 1. You see that? If we make it 1 in here, just to make sure we're on the same place, what are we going to get? You can tell me. Yo. Let's run it. We get red, right? If we put 2 there, we get 3.5. You guys get the idea, right? So the last entry will be 4, the 4th index. We run it, we get 1. But if we say anything outside of those indexes, if we say 5, something outside, we're going to get an error. And it's going to give you this error, this index out of range, because there's no 5th value, there's no 5th index. It ends there. Okay, if we say say we say -1 outside, if we say -1, it also gives us an error. Okay, so this is how you index lists, and it's very important you get used to that idea. Okay. And the thing is here, like, just note, like, Python is very math-based. Like, you guys, you're engineers, we should be very comfortable with math. So math complements Python, which is So they work together, which is nice. So you can replace variables. Instead of calling this 0, you can call this I. Or no, actually wait. Yeah, call that I, and then you can say I is equal to 0, right? You run it, and you'll see 1. And now you don't actually have to go inside, you can just make that 1. Right? You guys get the idea. Okay. Two thing, right? And now I'm printing this int value because it's like, to just understand how the code flows. I is 1, it puts 1 in there. Then it's going to go to the list B, it's going to see what's 1, it's going to put red. Then it's going to be red in there. And then int is going to equal to red, and then print int, so it's going to return red, right? Right? So you understand that flow? Now what you can do is as well, instead of just doing all of that work, you can just say I is equal to 1, and then just say print B of I. And now it's going to assume that this is a value, not an object, not a name. Okay, making sense? Yes, no? But you basically like just to see the value quickly, instead of having to write all of that. Okay, so we're also looking at operations for lists. Okay, so then the next thing is so that's indexing. The next thing is, what if the number of entries in a list? Right, that's the very next thing. So how do you see how many values are in a list, or how many, basically the number of entries / objects in a list. So, and you use the len function. Len, you use this is how you see it. This gives you number of objects in a list. Let's rather just put it here. You use len. Doesn't make sense. Okay, and how you use that, I'll show you quickly. I'll just wait for you guys to type that up. Okay, let me just scroll up. Okay, so how you use that, so I'm still gonna, let's create a new list. Let's call it list 1 or something. List 1, or let's call it list 1. And we're gonna say 1, 2, 3. Right? Again, just a simple list. Remember, you can have any entries in there. And then we're gonna say print len of list 1. So remember, we want to see the value. And if we run it now, how many entries are in here? How many objects are in here? 3. So let's run it. We'll see we get 3. Simple, right? Get 3. Okay. So, and you can even use B. Let's use B as an example. Let's do B. So the thing is, let's print B. The thing with Python, wait, I forgot, I lost my train of thought. But anyway, so just get rid of this print here then. But actually, wait. Like, so if we look at B, you see it, there's 1, 2, 3, 4, 5 objects in B, right? Remember that? So we see that when you say length of B, it's going to return 5. But say now we want to differentiate. What is this 3 and what is this 5? And we can make it look nice. So this is where strings come in handy. So what you're going to do is you're going to say, put a little some empty text, say list 1 is equal to, and then just put a comma. Put a comma, and then do the same thing here for print B. Print, and then just put list B if you want to. List B is equal to, and then whatever you put in the text, it will print. And then just, so what the comma does is it just separates text. Okay, just separates text. So put here comma, separates separates printing of objects. We run it, and we will see that, can you see a list 1 is equal to 3, list B is 5. And you can even come here and you can put another comma there. You can say say this is like meters or something, meters for units, and this is kilometers. Okay, kilometers. But you must remember, always put a comma and you run it and you'll see it's going to add it. Do you guys see this? So that's the purpose of string types, is it allows us to, you know, it can make the print look nice. That's one thing. Yeah, so you can just, it's a small thing, but it can make it look nice. So remember, you're building a calculator. So when you want to see things, say you're determining velocities, and you want to see the output is velocity is equal to meters per second. And then you can add it. You can be like, something like this. Say we have V is equals to 10, and we say print, and we say velocity, or V, say it's a function of time, and you say V0 initially, right, is equals to, put a comma, put V there, and then put meters per second. And run it, and we'll see we get this. See this? And then you can even check, you can even put like spaces in here, and then it will change this. Okay. And then just take note of this as well. You can write the exact same thing. Instead of using commas, you can use a plus, and I'll show you how that works. So plus allows you to join text. Remember I said you can't add a string and a number, right? Remember I said that you can't add a string and an integer or a string and a float. You can't say red plus 3. It's not going to work, right? But if you convert 3 into text, you can, and I'll show you what I mean. So say we want to do the same thing with this list here, right? And we go print, and we're going to say, once again, we're going to say the same text. We're going to say the text here. So the commas just separate what you want to print, right? Oh wait, let me just, I shouldn't do this. Okay, cool. Then what you do is you say plus, and then you're going to have to convert the string. You're going to have to convert string. And you guys must take note, like it might look confusing, but just take note of this, right? Like you can even call it, if it's confusing for you, just say the number of entries, call them int. Int is equal to the length of B, right? And then inside here you can call it int, right? But remember, I want you guys to understand, when the code is running, it's not, you see you have int in here, there's int, and what is actually here? Tell me, what is actually inside here? Int. What is in int? Who can tell me? What is int? What is it? What does int do? Like what is int? What is the value of int in this case? Because here's b. B is, yeah, so int is, and what would that be in this case? Yeah, so 5. So in reality, it's just 5 over here, so it's 5 in there. But it's going to convert the 5 into a string, the number into a string. So if we run it now, let me just put a space so that it doesn't look so untidy. When you run it now, you see we have list B is equal to 5. Let's rather call this entries. So just note this, rather call it entries at the top here for the list. So print list 1 over here, just make this entries at where the commas are. Okay, plus joins the text. Okay, plus joins text / strings. Text types or string types. Making sense? Yes, no, yes. Okay. So when you run it now, you're going to get list 1 is 3 entries, list B is 5 entries, and list B is equal to 5. But what it's doing is there's text here. Can you see that? There's text here, so it's added the text together. So it's joined the text, plus joins the text, right? And then if you want to add the other thing is we can say entries. Now you see we must make sure it's a text, you're adding text, right? And you run it now, and we see, but you see like, here with the commas, we just put commas and everything works out, right? It puts spaces, and it put everything for us. With text, it joins, you have to put a space in there, and you have to put a space in there. Now if you run it now, we'll see that it looks better. See that? It's small things, but they can make a difference, because you'll probably see this in the lecture notes, and you're like, wait, what is this? What the hell is str? Okay. My goal is to give you guys all the fundamentals so that there's no confusion when you're doing your lecture notes. Okay, cool. I'm going to continue quickly. Actually, wait, I'm tired now. I'm going to take a 50-minute break. Okay. Okay, so yeah, let's continue. Okay, so is everything clear from what I did previously with object types and all of that stuff, right? But just go through the notes. That's all makes sense. Now let's move on to the next thing. So we've defined the different objects, but now the next thing is functions, right? And we need to, and I'm sure you've been introduced to functions in the previous tutorial assignments and in class, and there's just functions going all over the place, right? So a function, like, so remember I said there's a toolbox. Remember there's a module. Remember I said this, there's a module, and in the module, there's different tools which are your functions. Now a function is just something that it takes in an input and then it returns an output. So it's like, you know, like a machine. You know a machine, like you say you put a block of steel inside it, does some stuff inside, and then output is it's like a, I don't know, like a, what, give me an example. Block of steel comes out as an engine or something, right? It's like an engine. It's a block of steel, there's your engine. But now, so basically what a function does is it takes in some stuff, it does some stuff inside, and then it returns an output. But how you define a function is, so the first thing you must know is you say df. That's the first thing. That's defining your function. So this is your function name. So the standard thing looks like this. So let me just look like df, your name, and then your objects that you're putting in. Your objects that you're putting in. You can put one object, you can put multiple objects in, and then tab return, or a hashtag. So just put a hashtag there, return, and then your once again you're returning objects. But basically, so actually rather call this input objects, input objects, and then I'll just take another thing. Input objects are used in the code. Input objects. Pardon? So basically, I'm just like, I'm not saying this is how you're gonna code it, but I'm just using comments to give you a general formula and an idea of functions. So we have input objects. So this is the input objects go into code. They must all be defined there, right? And then there's some code, does some stuff, and then output object come out. And I'm going to explain to you exactly, I'll show you a little example of how that works. Okay, then it's output objects. So basically you have a function that looks like, say you want a function that sums a list, right? So let's call it sum list. Finds the value of a list. Sums any list together. So sum list, what object are we putting in? We're putting a list inside. So we'll just call it B. We'll call the list, wait, let's find, let's say D, as in, whatever you want to call it. Like let's even just call it like list 1 or something, right? So we have def sum list 1, we're putting list 1 inside, and then we put you have to put a colon, and then we get inside the code. Just note this. Anything in the indentation inside the code, anything in here that's indented here, you see that there's a space here. Anything that is indented here, right, anything here falls under that function. So anything in here, that's part of the function. That's inside the function. So I'm sure you've heard the lecturer talk about global frame and local frame. So local frame is everything inside the function, okay? That's your local frame, that's inside. And then you have your global frame, which is everything outside of the function. Okay, so all this other stuff, all the other code outside of the function. But I don't like using technical terms. I just want to say there's code inside. So basically a function is code with a name. So it's code that does something and you just give it a name so you know what that code does. So if you look here, if you look at this thing here, this monster of a code I did here with the Sudoku, you'll see that I define a function here, right? Now what this function does is it takes this S, which is an object, an array. I know we're not really familiar with arrays, but I'll explain it just now. It takes an object in the array, and then it does some stuff to it, and then there's another function inside. So you can put functions in functions. You can define a function, but that's more advanced stuff, which I'll get into at a later stage, right? But the idea is that it takes some inputs, and then this thing has been used in this code, and eventually, right at the end, there's an output. So if you look here in this thing, like this overall function, this is a Sudoku solver. That's what it does. It solves Sudoku. That's the function of it. So that's what the code does, right? Then there's inside the function, there's different functions. So you have a function called this is a solution check. So it checks that the solution is correct. Inside to make this function, there's other smaller functions. I know it looks a little bit complicated what I've done, and it's the first time you guys are seeing this, but I just want you to get the idea that functions is code with a name. Whatever the code does, you give it a name. Okay. So let's go back to our our Jupyter notebook. So we're creating a function here. Create a function. So this is generally how the question would go. It would be something like this. So I'll put here question. So this is a question. It would usually be like this. Create a function that takes, create a function, it would usually be called, create a function called some list that takes a list as an input and returns the value of the list. Okay. I'm gonna go a bit quick now because I need to speed up because we only have 20 minutes. Value of the list, right? And then remember, I'm recording this for you guys afterwards to watch. Watch this. Remember that if you distribute this to your friends in any way, this is please don't distribute this to your friends. You guys did pay for this. It's only fair that you keep it to yourself, right? Okay. Pardon? Exactly. It's a lot of money, and you wouldn't want this to go for free, going free. You guys paid. That's not really fair if you think about it, right? So yeah, so we have def sum list 1. So the first thing you're gonna do is so remember what I said. This is the input. This is what's going in there. Remember, just treat it like an object. This is what's going in there. You don't have to define it. This is like the name almost. This is a name, a variable. This is a variable you're putting inside. So just right there, variable. That's a variable, input variable, right? And then we're gonna say, so we have def sum list, and we're gonna call list 1. And what you can even do is you can do this return, and you just sum and then list 1. So what you're doing is you don't even need code in this case. You can do it like this, simplest solution. So this is the simplest solution. This is the simplest solution. Simplest solution, right? and then we have our simplest solution. What was I doing here? Oh yeah, and then we have less simple. Well, you'll do something like this. So just copy the code, and instead of just putting the return straight in there, you're gonna say once or my sum or something. My sum is equal to sum list 1, and then we'll put here my sum, and then you'll just return my sum as an object. Okay, so this is generally the most simple type of this is a simple function. So how Python runs this, right? So if I say I'll do that just now. But now how Python runs this, right? If we run it now, nothing's gonna happen. Just run it, see for yourself. Run it, see what happens. So I'll just wait for you guys to finish. There, and run it, and then you'll see that nothing happens. Nothing's outputed. Okay. Okay, you guys still typing out code? Okay. Okie dokie. Okay, so you'll see there's no output, right? So what you'll need to do is, there's no output. Okay. So what you need to do is you need to call the function. So how you will call the function, you will say print. Basically, if Python sees that you want to return it or you want to print it, you can either do this. You can just say, okay, you must define the inputs list 1. You don't even need to call it list 1. You can call it anything you want. Call it this input's only important for what's inside the code. This input here is only important for what's inside the code, right? So we have list 1. You call it L if you want to, and we'll call it 1, 2, 3, and then we'll just say print some list, and then we're going to put L in here. Now this L is going to be equal to this list 1. Okay, you don't have to call it list 1. You can call list 1, but you can just get the idea that there's an object in here, there's objects in here. Okay, is it making sense? It's a little bit weird what I'm saying. Does it, like, just we'll run it down, we'll see. But when you print this thing, this is going to print whatever it's returning. So if we run it now, you'll see we get 6. So if I say my sum plus 2 as an example, okay, I'm just going to comment this out because I want to use one specific one as an example. Right, I'm going to use this one just as the example. If I say plus 2 and I run it, you'll see it's going to output 8 because it's only outputting this part, okay? But it's in relation to this. You can even put the 2 here, and then get rid of it here, and you'll see that it's going to print 8 because my sum, whatever the value of my sum is, it's going to return that value. Makes sense?
How does it know one is
because it's an object. Remember, so this over here is basically like the value or the variable, but let's say the value. So the differential, the function knows. So basically, when you define the function, this object, the input, is like your objects, right? It's assumed that they're known. Treat them like they're known. But remember what happens if you run a code where the answer is not known. Like if I say this, if I print P, right? P is not known. I run it, it's going to give an error because it says P is not defined, it's not known, right? However, if I say P is print, I say P is equal to 2, and I run it now, P is 2, right? Because it's known. So with a function, it treats this as if it's known. It's like the value, almost like the value, right? And then that's value, or the object, goes in here, and then it just treats it like normal. So when you run it, but that's why you have to define the object. So when you whatever the object is here, it's going to be here. Does it make sense? Is it making sense what I'm saying? Like basically, okay, let's understand this. So if I say, okay, so if I say x is equal to p, and I print x, what is x going to be? You can tell me, what is x going to be? Because remember, here's p, now here's x, I set it equal. Now if I say print, it'll be 2, right? So basically what's going on here, this is the same idea. What you're doing is you're defining L first, so you're defining P like this, right? And then over here, when you put it here, Python is automatically setting L equal, so basically here, L is equal to list1. It's equal, like this is what it's doing. List1 is the object type, which is basically, which is equals to 1, 2, 3. Okay. And then so it's putting this in here, over there. It's 1, 2, 3. So it's basically this is what it is. It's putting that in there. And then it does stuff and then it returns the sum of it. Okay. But remember this is recorded. I will you can listen to the thing, okay. Cool. But just you're not gonna get it now. You need to do more problems, you need to understand it. It will make sense. It took me like a month to understand functions when I first did it. I didn't understand it first time. So you will understand it, I promise. But just understand that whatever you're putting inside there, you can have multiple inputs, which I'll show you in the next example. You can have whatever you're putting inside. It's going to go in there, and you're printing or you're returning this. It's important. You must know what you're getting in and what you're getting out. That's what's important, okay? And how the code works. But I'll do that with you guys now. Okay, so let's go to the Introduction to Engineers book quickly, just to understand math and functions together. So we come here. So this is, come here quickly. Chapter 1, Chapter 2, Chapter 3. Okay, we're looking at Chapter 3, right at the end. So basically we finish with names and objects, looking at functions. But so if we look here, these are the equations. So I just want to give you guys a pro tip, right? I'm not going to do this with you now. Actually, wait, let me actually do this one with you, just so that we're all on the same page. Let me just do this one with you quickly. So if we look at this one, so we have, I'm going to just put this here. Let's open that there. Okay, so we're looking at this one there. Okay, so this is, I think this is IPE, Introduction to Program for Engineers. This is 3.3 quickly. And I just wanted you guys to get the idea. So let's treat this like it's a new example. So we see here, they want you to just compute whatever this is, because it's the calculator. Now don't go and try and do all of this in one line. Separate it. What I mean by that is, okay, so the first thing we realize is we have pi and we have e. To get e and pi, you import numpy as np, numpy as np, alright? We can just ask, all of you guys going to come back for the second session? Can I ask rather, let me just focus on this stuff, and functions is really honing on functions. And the next session, like the session 2, I'm going to also do arrays for loops. Okay, so let's just get our idea around functions. I think that you'll benefit more than if I just try and rush it now and I'm basically doing the same thing in the second session. Okay, so import numpy as np, and okay, but now the one thing is, if you realize, right? So usually what you'll do is you'll say p is equal to np dot pi and e and stuff, right? But before you do this, don't really worry about that. So yeah, we're doing IP 3.3. So we can import numpy as np. Or what you can do is, remember that I said a module is basically a toolbox with different functions inside it. So what you can rather do is you just say from numpy import pi. So we get everything at once. Pi. We also got square root as well. Square root, which is RT, and import e. Okay. Okay, so we'll say, okay, so break up math things, because you're going to get stuff like this. You're going to get equations like this. Usually you'll get like a sigma, a series of this, and that's more for loop and array stuff, but don't worry about that too much right now, like with regards to arrays and for loops. But it's important that you understand how to do the math of these things. of equations like this. So how we do that is we're going to say, we're going to say from NumPy input this, and we're going to define, break it into parts. We have A, B, C, and D, what's in the brackets. So the first part we'll call it A. You can call it any part you want, but I'll call it A, and we'll say pi plus 5, right? But remember, so now we don't need to say np.pi anymore because we've imported it. And then we will say B is equals to square root of 5 minus x minus e to the power of 2. Now, minus e to the power of 2. So I'm going to call this version 1. This is version 1 that you can do with just when you have e, and then version 2 I'll show you the other one. But right now we're focusing on this, and then we'll call the other part c. So 1 minus e to the power of pi, right? And then we have d equal to 1 plus pi to the power of e. Okay, so now we've broken up that into parts, and then all we do is we say our answer is equals to a plus a. So if we just look at this, so we have a times square times 2 times b divided by c times d. And you can even try in a calculator and what that answer is if you want to. See if you're right, and then you'll run it, and you'll see that we get 0.65 something. Okay. This is version 1. Version 2 I'll show you now. Quickly. So you'll see you get this. Do we all get this? But it's important, what you should take away from this is that you should break. You see a complicated math thing? Look at what's given first, like there's e's and stuff, then import them all, and then break it up into A, B, C, and D. Because this is one of the biggest mistakes I see students do. And then what happens is if you don't do it like I've done, you're just going to have brackets on top of brackets. And I'm not even going to show you. You're just going to have brackets on brackets, and then that's going to cause an error. Okay, that's that. Now what I want to show you guys where functions and all of this comes in is, let's look at question 3.4. So here's a question. Let me just zoom out a bit. Okay, so this is the question we have. So they say, this is question, so this must be 3.4 then. Here. Then IPE, let's copy this. Oh yeah, sorry guys, there was something I just wanted to show you in the previous one. So this was, in the previous one it was that version. What you can do is just copy and paste this code. Copy and paste all this code here. And then call it version exp. So what I'm doing here is I just want to show you that there's two ways you can use e or exp. So you can just use e and then that's your natural logarithm number, or you can use exp. Now exp works, just take note of this. Instead of saying to the power of, you're going to do this. Let's say exp and then just 2. So it's going to find the exponential of 2. Okay? And then wherever you see that, you just replace e with exp and then put the exponents in brackets. And then say exp here and you make it 1. Because e to the power of 1 is e, right? And then run it now, and you'll see we get the same answer, more or less. Okay. What? What error is it? Read the error. Yeah, you see, it's small things. You need to watch out for. It's small things in life. Hard because you might get a little error in the semester test. And your code doesn't work, and now you're stressing, and time's going, because you know you only have 20 minutes to do this, and no matter what you do, the error doesn't get fixed. But just read the error, look at your code. When you're coding, just focus. Don't just focus your mind on what you're doing and so forth, and there won't be any errors. But the worst type of error is so you get what's called a syntax error, and you get a logic error. So syntax is like the words you use. You know, like in this case, it's the language, how you tell the computer what to do. Like everything, from everything. The equals to, the a, the numpy, the everything, the way that it is. And if something's wrong, if you leave out a comma here, if I leave out a comma and I run it, it'll be invalid syntax. That's basically a syntax error. I left out, there's a mistake, I left, right? Okay, but then now, as an example, let's say there's like a logic error. If I do this and I run it now, so I took out an exponential thing and I run it now. I mean a logic error. So you see, it's still right. The code still runs, right? Everything works perfectly. But then it's like, why are the answers different? Because I left. This is supposed to, and then you go through the code and you're like, oh wait, that's supposed to be exponential. You see, it's like small things, and those are the worst type of errors because the worst is if the code runs, it doesn't tell you where the mistake is, and you have to go find the mistake. So those are, imagine when you want to code something like this, and it doesn't solve the thing. Now I have to go and I have to figure out the bugs, and that's pretty much programming. So respect software engineers. Okay, where was ours here? Okay, so we run it. If we run it now, we'll see that it's back to normal. Okay, cool. So just take note of that EXP thing. Now let's come back to Introduction to Programming for Engineers, IPE. Now we're just going to look at this question, and then we'll do question 6. You can do question 5 on your own. Okay, we'll do question 6, and you can do question 5 and stuff on your own if you want. Like, put that as homework. Say question 5 for the IPE. But question 6 I'll do with you, and then we're done with functions. Okay, cool. So if you look at this question, they say calculate the velocity at a given time defined by this. Now, they don't give us the value of m, they don't give us the value of anything, right? So we're going to have to create a function for this, because if they don't give you value, the only thing to do is to avoid an error, you just use each one as an input. So what you can do is, you can do something like this. You can say df, v is a function of, yes, it's a function of t, but because mass is not known, the mass is not known, the area is not known, the density is not known, what else is there? And then your coefficients of drag is not known. Mechanical engineer. No coefficient of drag. Okay, so we have this. So those are inputs that we're putting into this thing, right? But now if you look at G, G is known. We all know that G is 9.81. And now if you ask me, is it minus, is it a plus, just look over here. We're putting a square root in, you see there's a square root here, right? If there's a negative in the square root, it's an error. So just make sure that, in this case, G is positive. So just assume that downwards is positive. Okay, civil engineers, SWK. your fourth diagrams. Okay, so we have G is equal to 9.81. So let's break this into parts. Okay, so we see so remember what I said is, so we see we have a square root, and we see we have a tan h. So let's import these things. You can either import it inside the function, we can import it outside the function. Doesn't really matter, but we're going to import it outside. So we're going to say import, we're going to say from numpy, import tan h, and then we're going to import square root. Okay. So and then you just break this into parts. So we're going to say b is equal to for the inside part we'll call it B, so we'll say 2 times M times G, right? Times, and then divided by, and then we'll say dent P times A times CD, right? So that's our B, and then inside we'll call this inside here, we'll call it, say, C. And we'll say C is equal to, but just make sure that variables do not overlap, right? Because if we see we have CD and we have C, so let's rather call it something like Z or something. Something that where the names are unique. So we'll call it Z and we'll say that's G times P times CD times A divided by 2 times M. And then, so V then is equal to, equal to square root. So you guys following me? Square root times what? You can tell me. Times what? What am I going to put in here? Pardon? Okay, I'll just wait for you guys to catch up then. And the thing is, it's only this session I'm recording. I'm not recording the other sessions. Because it's simple, right? Like then students are going to realize like, hey, let me not go to the session, I'd rather just wait for the video. No. I'll give you guys this video because these fundamentals are so important. And you're a small group.
How many people was in the previous?
There was a lot of students. It was like 20 something. Okay, are you here where I am? Like, are you here? Okay, so square root. Now you have to use. Now what am I going to put inside the square root? Like, well, what are we squaring in this case? Or square root? Huh? B. Yeah. So do you guys understand why I'm putting B in there? So what is B? Yeah, just B, right? B over here. This B over here is this thing inside here. It's this part. That's B. It's hard to find it because remember we break it up, right? And then our Z over here is this part inside here. Does it make sense? So if you look at it, that's how to find it. So then you break it up how you want to. Then square root times tan H T times T times square root, and then we'll put Z in here. And then watch out for brackets. Make sure all the brackets are there. Cool. And then we're going to return V because that's what we want. Okay? And then we're going to print. Now we want to see what the values of V is. So we can call it, so we're going to define T. We'll say T say equal, let's say this is seconds, 2 seconds. I just put a hashtag for seconds. Just the comment is just for show. I mean, just so that we can see that that's the units, right? Python doesn't take that into account. Then we have M, which is equal to 10, and then we can say kilograms. Okay, and then we have CM. Okay, then we define the variables. We have our cross-sectional area, which is 5 meters squared. And then we have our density, which is equals to, say, 7 meters, or no, kilograms per meters cubed. And then we have our CD, which is, what is CD? It is coefficient of drag. We'll make that 0.5. And it's unitless. So we have our, remember, before you define the function, you have to define the objects. It needs objects. It needs values. Objects values. It needs those. Okay. So then now we can call the function. So we can call it anything you want. You can even call it V is equal to, and if you put this here, but though it might give you an error because the names are the same. So try and give the output and the name something different. So call it V1 or call it VT. VT is the output. Call it VT. So write that down, guys. What I just said. Like, make sure that because you make the function, make sure the function and the output are the function name and the have different names. So when we import it, we'll say VT. And you don't call it VT, you can call it VT1 or call it Bob if you want. Call it Bob. Bob is equal to, and you take this over here, and you paste that there. Right, now remember, all of these objects are defined, all of them have a name, so then we print the value of Bob. Let's print Bob, and you run Bob, and you'll see that that gives us 3.34 blah blah blah. Like, do we all have that same answer? But then I just want to show you here. If you wait, what was I looking for? Oh, yeah. So remember that there was this Python visualizer thing, right? So let's go back. Okay, so I'm going to put a code in here. So I'm just going to keep the code the same. Just note you can't put numpy in here. You have to use math if you want to do things. So as an example, if I say import numpy as MP, and I say print np.sign say 20, and I run it. See, it's apparently worked. No, see, it doesn't work. It says import error, numpy not found or not supported. So this thing can't do numpy. I don't know if NB tutor can, but a solution around that. And you're not really going to use it for stuff like that. You're going to use it more for like you use this thing to visualize for loops. Like, how does a for loop rhyme? Because once you're like a for loop in a for loop in another loop, it's like, what's going on? Like, my brain doesn't get this. Nothing at all. Don't worry about that. MB tutor. It's just it's a thing. It's optional, just to help you visualize code. It's basically what this thing is doing. But rather, so a solution around this is rather import. Just go back. Import math as M, and then just say M dot. Right. But now I just want to put some hashtag stuff. So I want to say like hashtag M dot cos say 30, right? And let's make this x is equal to. Now if I run it now, or no, let's make it t. If I run it now, we'll see that, okay, so import math as M, we say next, it imported it. So what we should see now is this. So what's important is, let's get rid of this errors here, so just close this thing. So, okay, so when it starts off, you got this, right? Then you press next. So the red line is not where you are, it's what's going to run next. You go, now look at the green line. So it imports it math as M, see, so it says global frame, which is like your, I don't know, overall thing, like a big library. Big library is a global frame, and then a small one is a local frame. Like a small function. Basically, a function is a local frame, right? So write that there. Function, local frame, global frame is a module, because it's like a whole thing, the whole thing. What is this lecturer saying to you guys? What is the lecturer saying to you? Like, what? Huh? And have you told him? Has anyone told him? I'll ask him. Can I help you teach? Because you know I'm a teaching assistant for the university, so. And just note, like, if you guys ever want to consult with me for free, I consult for the university, so 9:30 to 11:30 on Fridays, you can come through. Okay. But there might be other students, I don't know. But just last week no one came, so 9:30 to 11:30. Okay. But yeah.
Yeah. The first time both of the lectures, like the I don't know what.
Yeah, I think a lot of these lecturers, they forgot what it was like being a student. Because I've just been looking at research papers and stuff for so long. Right. But anyway, but I still like, you know, I still respect lecturers and what they do. But anyway, let me just show you here what this thing's doing. So import methods m, and now we're looking at the next. Oh wait, back. So look here, right? You see this hashtag code? I want to show you. You see this hashtag code here? See it's here, no? Now this is where we are. The next line that's going to execute is red. Do you see this? It skips this line. Doesn't look at it, doesn't see it, doesn't read it, doesn't go into its memory whatsoever. Python doesn't see it. Just, it's gone, it's like blank. Does that make sense? So look, when you run it, and then 10, now x is 10, y is 15, and then it prints y. You see, there's the output of y. So this is what's going on in the back end of Python. But when you're doing the lecture notes and stuff, you need to understand how is the code running. Okay,